Welcome to the next day, I guess. So we're in a little bit of a flashback here. We were on a study now with matrices was really one of the lessons that we taught last spring when we kind of went on into this distance learning thing. So what I'm going to have you do today is you're actually going to listen to the video that I made for the inverses of matrices and the determinant of matrices that I made last year. So it's a pretty short video, which is uncommon for the ones that you've seen this year that have been a little bit longer, but it should be good. So you're going to hear some references in the material that probably don't make a whole lot of sense, as in you're going to take this quiz, your weekly quiz at the end. There's going to be a couple other things that I'll throw some things up there. There's a part in there that says you don't have to do this, the scalar multiplication part of it, but you are going to do the scalar multiplication part of it. And I'll kind of make reference to that to make sure you understand what I mean when we get to that. But get a little bit of a throwback. You don't get to see my face, which is probably good. But it's a good lesson, nice short lesson, and it gets you going. And when you're done with this, you can go ahead just complete the assignment. Obviously, don't worry about some of the things that I talk about at the end because you don't have to do those because I'll either see you in class or I'll see you in class. So enjoy the video. Don't have to see my face. A little bit of a different aspect of how we used to do these. So have a great day, everybody. All right, so lesson 2 for the week, inverse matrices. So in this lesson, we're going to do two things. We're going to find the determinant of a matrix, show you how to do that first, and then we'll determine if a matrix has an inverse. And if it does, then we're going to go ahead and find it. So the determinant of a matrix. We've talked about matrix before. If we just look at a kind of a standard matrix, a 2 by 2 matrix, A, B, C, and D. Now the determinant is actually what we're going to use the determinant for is we're going to use it to find the inverse of the matrix eventually. So we need to be able to find the determinant before we can find the inverse. So what the determinant is the determinant is just going to be a value. And that determinant that we're going to use, or the formula that we're going to use to define the determinant, is we're going to take A times D. So we're going to go crossed here. We're going to multiply A times D, and we're going to subtract from that B times C. And that's how you find the determinant of a matrix. So for example, if we have the matrix 3, 0, 2, and 4. The determinant for this matrix is going to be 3 times 4 minus 0 times 2. So 3 times 4 is 12. 12 minus 0, 0 times 2. So the determinant for this is just 12. That's the determinant for that matrix. And we are only going to do the determinants with 2 by 2 matrix. We're not going to go any further than that. So let's say we've got 4, -6, 3, and 1. And we're going to define the determinant of this. So again, that would be 4 times 1 minus -6 times 3. Scroll up a bit so you get that out of the way. Sorry about that. Just got an email. So that gives us 4 minus -6 times -3 is -18. So that gives us 4 plus 18, which is 22. So that's the determinant. And we're going to need that determinant now and be able to find that determinant in order to help us find what we call the inverse of the matrix. And so there's the first part of today's lesson. Pretty straightforward, not too bad. Second part of this then is to being able to find what we call the inverse matrix. And we're going to switch over camera views here real quick. We're going to go to inverse matrix. If you remember, we've talked a lot about inverse matrix in the past. And really, when we're looking at doing inverses, from a mathematical standpoint, what we're really trying to do when we're trying to find an inverse matrix is, let's say we have the matrix 2, 3,
4 and 5. We want to figure out what values, let's say W, X, Y, Z. We want to find these values so that we have what's called an inverse matrix. And that matrix then, this A times what we'll call A to the negative 1, that has to equal the matrix 1, 0, 0, 1. And there are ways to do this. We could use the multiplication that we used the other day to do this, where we took rows times columns, and we could solve for W, and we could do all of that. It's kind of mathematically how it's done. But instead of doing that, what we're going to do is we're just going to use the formula for the inverse. And here's our formula for the inverse. And now this is only if this exists does this work. Remember, this means inverse. So the inverse is going to be 1 over the determinant of A. So we're still going to have to find that determinant. And then we're going to take that times our matrix. And let's say that our matrix, I need to give our matrix a value. Let's say that we had the matrix A, B, C, and D. So that's our matrix. The inverse to that matrix is going to be 1 over the determinant times D goes here now. Now this is going to be negative B, this is going to be negative C, and this is going to be A. So from our original matrix, which was right here, the A and the D are going to switch spots when we find the inverse. And the D and the B and the C are going to be in the same locations, but they're just going to change signs. Okay. So what we're going to do when we find this, and let's go to our original problem that we had up here, we're going to find the determinant for 2, 4, 3, and 5. I'm sorry, we're going to find the inverse for that. So the first thing we need to do is we need to find the determinant, because our inverse is 1 over the determinant. So we find the determinant first. So the determinant is going to equal 2 times 5. That was A times D minus B times C. So 4 times 3. So that's 10 minus 12. So our determinant is negative 2. Now we have to have a solution for this. Okay. We have to have a solution. If this is 0, then this doesn't have a determinant, because remember, you can't divide by 0. So if this would have been 0, we could have said that the inverse does not exist. But since it's negative 2, it's going to exist. So we can write the inverse to this. So A of negative 1 here is going to be 1 over the determinant. Our determinant was negative 2, so we're going to put 1 over negative 2 times. Now we're going to switch our A value and our B value around. So our A value was 5 and our A value was 2, and our D value was 5. So we're going to switch that around. So the 5 is now going to go up here. The 2 is going to go down here. And now we're going to change the signs of our B and C value. Okay, so it was negative, it was 4, so this is going to be negative 4, and this is going to be negative 3.
All right, so at this point in the video last year, I told them that they did not have to do the scalar multiplication for this part. However, you guys will be expected to do the scalar multiplication for this. I think I repeat it later in the lesson again that they don't have to do the scalar multiplication, but again, you do have to do the scalar multiplication.
Okay. So let's look at a second example. Let's look at the matrix 4, 8, 2, and 4. So here's our matrix. We want to find the inverse matrix if it exists. So step 1, we're going to find the determinant. This is kind of this step 1. So the determinant is 4 times 4, which is 16, minus 2 times 8, which is 16. So that determinant is 0. Since this is 0, this doesn't exist. So there's not an inverse for this one because this determinant is 0. Okay, one more, and then we should be good. So let's go with -3, 2, 4, and -2. Okay, so step 1, find the determinant. -3 times -2 is 6. 4 times 2 is 8. And remember, you subtract these. So our determinant again is -2, which is what we had before. So there's our determinant. So now we're going to find the inverse. Oops. So we're going to find the inverse. So it's 1 over our determinant. So 1 over -2. And then we're going to take it times. Okay, now our a value and our d value switch places. So this is going to be -2. This is going to be -3. And now these two, our b and c values, switch signs. So that's going to be -2 and -4. And that's your answer for your inverse. Okay. So there's finding determinants and finding their inverses.
So if you have any questions on it, please make sure you ask. Otherwise, the assignment will be in the 3-3 folder. We will be having a quiz over this material, looks like on Friday of this week, and we'll also be starting the next unit on Thursday and Friday of this week. Have a good day.